So I'm sharing my screen. So hello everyone, welcome to our last session of interactive learning sessions of Corda 101. I'm Iryna from R3. I'm a developer evangelist, and I'm helping you to learn Corda. And so today is our last session, and we'll be leading this session today. So we all know that Corda blockchain platforms are really hard, and so I'm developing this series of educational pieces for people to learn Corda. I will please put your questions if you have on the chat box. We'll allocate some time to answer them. And today we are going to look on RPC clients and flows across restarts. There is a small example for flows across restarts, and we'll start with the RPC client. So in all cases, so I will go directly to our example. So every time when we build CorDapps on Corda platform, we'll definitely want to interact with the Corda node from external application. And today I will show you how to make use of client proxy to make RPCs to the Corda node. And the RPC client can be written in any JVM compatible language using the Corda RPC client class. So you just need to override that Corda RPC client. Once connected, you can query Vault, trigger flows, and do many other things. So basically, you connect to your Corda from any external application. So I want to start mention that in Corda we use Apache Artemis for RPC communication, and at the startup, Artemis will be created on the client side and the Corda node side. So RPC client here is your external application, and Corda node is your RPC server here in this example. So you will make RPC request from external application to your Corda node. Once the client and server queues are created and sessions are enabled between client and server, we can query all the data. So the Corda RPC library contains a client proxy, which translates RPC client calls to low-level Artemis messages and send them to the server Artemis instance. And these RPC requests are stored on a server side in Artemis queues. And the server-side consumer retrieves these messages and makes RPC calls that were in that message recorded. And then send acknowledgement to the client that is what was made. Once the method completes on the server side, the reply is sent back to the client. And also reply is wrapped in the Artemis message and sent across by server Artemis to the client. So the client proxy within the Corda RPC library abstracts the above procedures types of this low-level communication between client and server. So that means that from client perspective, we just need to create a proxy instance and make these RPC calls. And so we don't need to handle any Artemis wrappers and queues, anything of this. So RPC is then RPC server exposes certain like RPC methods on the Corda node to the clients. There are like some of them are standard, and you can extend it to provide functionality that you need. And so, so there are two types of clients that you can create. It's a RPC client, which is one-time connection, and one-time connection and reconnecting RPC client. So one-time connection basically simply throws exception if a connection is lost, or if node is killed or fails, and clients expected to handle their connection logic, so it should be in a loop. And also client should keep track of triggered flows and the statuses, while for reconnecting RPC clients, everything is done on the server side automatically, and client reconnects itself to the node or once the node is up. So before start looking at the code, we need to make sure that we set up a correct RPC user and assign necessary permissions to the user in build.gradle. So it happens over here where we give in RPC settings, we give basically a localhost user password and permissions. Also need to include Corda RPC as a Gradle dependency in your client application. This is happening. So this is happening here. So in our dependencies, Corda release group Corda RPC. Once you include this library, you can get hold of the proxy and make RPC calls. So let's now look at steps how to make RPC calls. So this current file is a build Gradle in the project file, where again we need to establish create dependency and also give permissions. So I'm looking at the example, which is a Spring Web Server, which is online. I will put link to the I will give a link. No, chat is here. Okay, just found. So this is a link for the very simple Spring Web Server that we are looking today. And Bhanu is asking if it's a continuation of the previous session. No, in previous session we were looking at Corda services, and today we're looking at RPC clients, how you can connect to your to your Corda node from externally. So on this link, if you go, you can see server and folder of controllers. So what it means that in we have server where we create a server, and then node RPC connection is actually responsible to create RPC connection. And the controllers, we have a standard controller and custom controller. It's exactly the same project that I'm looking here. Standard controller provides standard endpoints, and in the custom controller we write our own. And this very simple example, we start with node RPC connection, and here we create in RPC client. Code RPC client is exactly the class that I mentioned. We will grab instance of this Code RPC client, but we need to specify node address here and the port. All these things are provided in a constant, which has address and port, node and port. So after that, we can create we can start the client, and we can set up like reconnecting proxy or one-time connection proxy. Here we do one-time connection proxy, and with a reconnecting proxy, we just need to pass gracious reconnect instance. But here, let's keep it simple and do it one-time connection. So after we do this, we start this client by providing username and password. So calling start on a client establishes an active connection between a client and Artemis server, and secure connection can be established with the server if specified by the client. And the next one, we are retrieving proxy. So Corda RPC connection encapsulates client proxy, which converts RPC client specific API calls to low-level Artemis messages. And Corda Corda RPC ops exposes RPC operations available to the clients, which we have here. So now we can use this RPC proxy in our standard controller. So in our standard controller, when we have this RPC proxy, we just call all the exposed endpoints from the node. So let's now start the node. So we do the same deploy. We deploy first nodes and then we run them. And after that, we'll start our server. So in this, we'll repeat. So now we start our server. Now we start our nodes, and this is our starting point for the server, where this we create app here with the Spring application, and we take our own class, which is server class, and then we take all arguments that are listed and run the app. So also want to mention that here in application properties, we can set up some the port for the server. If it's not set up here, then it will be defaulted to 8080. And on the when the server starts and it's instantiated with a node RPC connection here, just before it's instantiated, it creates controllers, which are standard controller and custom, by looking for any annotation that are REST controller, and request mapping with the base, and then it will create all these endpoints that are saying annotated with the values. And now we can hit any of these endpoints. So if I want to hit this endpoint, I need to go to localhost. 155. And if I want to hit any of them, any of our endpoints, I'll just add here base addresses, and I see the address. So that's how you will establish your connection. If you want to establish if you want to trigger your flow, you're doing it by running proxy and then start flow dynamic, where you put the class that you want to start. And then you provide arguments that you need for this for the constructor of this class. So we use Haskell asking why we need two controllers. So it's just you can put as many controllers as you want. And here I just wanted to show that you have these standard endpoints provided by default by the node. So you can get all the system and the entities platform version and peers for externally. So there is because they are by default, they will provide like node trees and flows. They will be provided, and then you can put your custom controller in different file, or you can put it all together just to make it easier, kind of from design perspective. So you can see which one is yours, which one are not, but you can put it in one class as well. So now I want to show you another example. So this is like briefly went through Code RPC connection. So let's recap it again. So we need server with a Spring Boot application annotation that will basically, this is a starting point for your server, for your node on Corda. Node RPC connection. This will be your here you create a connection to the proxy, the RPC connection, and this is the RPC proxy. This is initialize node RPC connection. We need to annotate with a post construct, and just grab RPC client instance and start with a user and password. And then from this, when you start it, you can grab the proxy. And when you have the proxy, you just in a standard controller, you pass it through the constructor, and then you just use this proxy to call your flows via proxy.start flow dynamic. Also, it provides with the node provides with the standard RPC endpoints like state, status, server time, addresses, identities, flows. So we were checking addresses. We can check the flows that are available. So this is how you would create this. This is how you would communicate externally with your node. The next example I wanted to show you.
Iryna, are you able to take a question now, or do you want to take them at the end?
Pascal, I will come back to you on the second question. The first one, it's basically, you can put in one controller on one file or in two files. It's just to make it easier to define which are default endpoints, which are not. On the second one, I'll come back to you. Tell me if I can find you on Slack, on Corda Slack.
Thanks, Iryna.
So the next sample that I wanted to cover with you today is showing you flows across restarts. So basically, in one of the examples, early examples, when we look at concurrency, I want on this example quickly show you that durability of the flows across restarts of the nodes. So when your node turned off, or when flow is executing, while flow is executing, and then it's basically starts where it left off. So when you restart your flow while there is some flow executing and there was and it was checkpointed, then when the node is up again, it will continue execution from the point where it was checkpointed, the last point. So if, for example, we have here a loop, and so loops for 50 times, and each iterating, we just we print the message and the number, and then we sleep. And I just want to remind you again that when the node sees sleep, sleep, send, or receive, or subflow functionality, it will checkpoint all the variables and the flow to the disk and free the resources so other flows can use the resources on the node. So it should be annotated with a suspendable, and you should use sleep, send, receive. While the flow, I will show you now that I will start running the flow on the node in this large loop. And then while it's running, I will stop the node by killing it and then start the node again. And you see that you'll see that the flow will continue printing numbers from this loop where it left. And basically, its flow survives across restarts because it checkpoints when you use sleep or send receive operation. So when you send a message to another node, then it will continue on, the flow will continue only when it receives from that node back. And so if you do sleep, it checkpoints there and remembers the last number and all last variables, and it will start where it last checkpointed was. So let's kill the other nodes. Go to so in Corda Java, I'm deploying the nodes by a wrapper of Gradle, and then do deploy nodes. So now I do build nodes. So I'm starting my nodes here. So again, in my sleepy flow, in my flow, I have large loop of 50. It prints the number, and then it sleeps for a bit, and then it prints number and sleeps for a bit. While it sleeps, it checkpoints all the variables before it goes to sleep to release the resources, and then it wakes up again and picks up on the variables that has been checkpointed. So let's start sleepy flow. And variables are the one from the constructor, which is a message, limit, and sleep time. So message limit 50, and then sleep time. Sleep time. So half a second, which is 500 milliseconds. So I will start this flow, and then it will start printing the numbers. Mm, that's right. So it start printing the numbers, and now I'm killing it. And so I kill the nodes, but if I restart them again, you see that it's continue printing from the time it's checkpointed last. So we start with 22 actually, which is here. So yeah, this is what I wanted to demonstrate today. There are like flows across restricts to demonstrate durability of flows. If it's been checkpointed, it's only this, you can see this feature, durability, only if the flow was checkpointed. If it was written on the disk, and then after that, the node was killed or restarted, the flow will be restarted from the time, from the variables that's been written on the disk. So that's it for today. This was our last session. I will thank you very much for attending the sessions. So I will send you email with a thank you on September, on 1st of September, and also with a code for free code examination. So Naomi, is it possible for you to give me emails of the people that that's been attending?
Yeah, that should be something that Women Who Code can generate. It just doesn't generate it until the webinar is like concluded.
Okay, yeah, okay, perfect. Yeah, thank you so much, everyone. If you want to contact me, so we are on Corda Ledger Slack. I'll just post it. I will post it here on the Corda Ledger Slack, so you can find me there. And so yeah, my name is Iryna on Corda Ledger Slack. I will answer all the questions. Thank you so much. This was our last session. So that's it for today. Hope you have a nice end of the day and a great weekend. Thank you.
Thanks so much, Iryna. Someone is just asking if you're able to elaborate a bit on the process of the exam.
I'm not sure I can elaborate now. So I think there are like some just test questions about concepts of the flow, state, contract, transaction, and you can I can send you some information online about it. Where is this question?
In the Q&A under that other API question.
Okay. So yeah, just you need to choose like bullet points, like questions. You can also go to, if you want to learn more, on docs.corda.net as well. I will send you some information if you contact me on email or on Slack.
Okay, thanks, Iryna. Sorry that the slides went a little crazy there. I've reset up my screen and don't quite have it all together. So yeah, for the folks today, if you're interested in running a webinar yourself, or you're curious kind of what that process looks like, or you know someone really talented in your community who can speak about blockchain or blockchain adjacent things, we're looking for speakers. You can send a note of interest with a short bio and topic to myself, Naomi@womenwhocode.com. And you can follow us on Twitter at WWCode blockchain. We'll be posting different kinds of events and study groups and things like that from there. That's about all for today. Thank you so much for joining us, and thank you to Iryna for running this wonderful series. We really appreciate it.
Yeah, thank you everyone. I also posted the link to the Corda certification where they put some information about what concepts they're going to be on the exam.
Great, thank you.
Bye-bye.
So we'll wrap up in now, but I'll leave the chat. I mean, I'll leave the event open for like a couple minutes in case you need to get any links from the chat.
Okay.
Thanks, everyone.
Thank you.